am Revati, Assistant Professor, Department of EEE, SNS College of Technology. In this lecture series video of Fundamentals of Electrical and Electronics Engineering, today's topic is mesh analysis. So, mesh analysis is commonly for applying KVL, Kirchhoff's voltage law. So let us discuss what is are all the components which we have discussed previously is a flow of current in a single direction, which is known as DC circuits. So we have discussed about Ohm's law, V is equal to IR, Kirchhoff's voltage law, KVL. So what is Kirchhoff's law states that it is basically have a two laws, first law and second law. First law is Kirchhoff's current law, which is the algebraic sum of all the incoming current is equal to algebraic sum of outgoing current. So in Kirchhoff's voltage law, which is second law, the sum of all the voltage across a closed path or a loop or any other circuit is equal to 0. So by applying KVL, we can analyze the mesh of the circuit. So what are all the topic we are going to discuss in this video is what is mesh analysis, steps to perform mesh analysis, some problems with solution and the real world applications of mesh analysis. So let us explore what is mesh analysis. So it is a method of analyzing DC circuits by applying Kirchhoff's voltage law to mesh current in panel circuits. So mesh, a loop does not contains any other loops within it. Purpose is to simplify solving for unknown current in the complex circuit. So n number of loops are there, n number of circuits, n number of resistance are there. So it is a simplifying methods to solve the current, to find out the unknown current. So reduces the number of equations compared to nodal analysis for certain circuits. So these are all the things which we are going to solve in the mesh analysis. So steps. So first and foremost thing is to identify the meshes, determine all meshes loops in the circuit. So in the left side there is a diagram which consists of 3 loops. So that is how we identify. First we have to identify how many loops are there in a circuit. So the first loop is I1 and the second loop is considered as I2 and the third loop is considered as I3. So there is two voltage sources in the given circuit, 130 volt and the other one is present in the third loop. So in first loop there are two resistance R1 and R2. So the R2 is shares the loop 1 and loop 2. So that is denoted as I1 minus I2. So in loop 2 there is 3 resistance present. So R3 is only in R2 loop. So whereas in R2 resistance share I2 and I1 resistance and R4 shares I3 loop and I2 loop. So in R3 I3 loop, so R5 shares I3 loop and R4 shares both I3 and I2 loops. So this is how we have to analyze the loop and organize the components. So apply KVL. So summing voltage drop across the components which is considered in the left hand side and the right hand side we have to consider I and R components. So which is nearly V is equal to IR, which is Ohm's law. So calculate branch current, use mesh current to find actual current in the branches if needed. So if needed, we have to find out branch current which is denoted as I0, that's equal to I1 minus I2. So some problems are here is 120 volt and 60 volt is called as sources voltage. So there is two loops in the circuit. One is I1 and another one is I2. Whereas in solving for first loop, we have to consider 30 resistance and 10 resistance. 10 ohm resistance is shares I1 and I2. So 120 that's equal to 30 I1 plus 10 I1 minus I2. So this is what we have to solve in loop 1 mesh equation number 1. In second equation we have to solve 60 volt that's equal to 50 I2 plus 10 I2 minus I1. With respective of I2, 10 is sharing both the loops. So we have to form the equation like that. Here then we have to solve the determinant method. So form a 2 cross 2 matrix which is R, I and V. So forming the 2 cross 2 we have to find out the determinant which is del and then using del we have to find out del 1 and del 2. Applying determinant equation Grammar's rule, del 1 I1 that's equal to del 1 divided by del. I2 that's equal to del 2 divided by del. So we can get I1 and I2. If we are need to find out the branch current to the circuit. I naught that's equal to I1 minus I2. So we find out I1 and I2. So subtracting these two components, we can get the branch current in the circuits. So this is what I have said in the previous slide. So equation 1 is 120 divided by 40 I1 minus 10 I2. So solving the second equation, so we can get minus 60, that's equal to minus 10 I1 plus 60 I2. So here we using the determinant method, I1 that's equal to 2869 amps, so which is I1 equal to 2.869, I2 that's equal to 0.521. So the branch current I1 and I2 equal to, so already that is in minus, so we can get 3.39 amps branch current. So this is how we can solve the mesh analysis. So the main objective of this mesh analysis is to understand the Kirchhoff's voltage law and familiar in analyzing and applying KVL rule, so that it is easy to find out the nodal analysis and all those electrical components, etc. So problem statement identification. Insights define the core problems, problem statement, DT aligned and core definition criteria we can achieve in mesh analysis. So basic applications of mesh analysis is power supply designs to ensure the distribution in DC power circuits, electronic devices used in smartphones, computers, gadgets, etc. Automotive systems to helps in troubleshooting in DC circuits and vehicles. Renewable energy systems optimizing the current flowing, solar panels and battery systems. So these are all the things which we are using the mesh analysis in the real worlds. So these are all the mind maps, whereas the mesh analysis in simple problems for solutions and simple mesh analysis definitions and all those things which comes under the mind maps. So these two links helps lot of problems to solve in the mesh analysis. Thank you.